Good morning, dear students.
Good morning, sir.
Good morning, sir.
Good morning, sir.
I welcome all of you to the class of chemistry on 3rd February 2021. My dear students, in the last period, dear students, we have studied about the resonance, how to write the resonance structures or canonical forms, and which canonical form or resonance structures contribute maximum to the hybrid structures. Now today in this class we want to study about the resonance effect. So first question that arises in our mind is, what is resonance effect? That is the question that comes to our mind, that what is resonance effect? So my dear students, we can write the answer very simple manner. Let us write the answer. I would suggest you even to write the answer parallelly with me. The resonance effect is, please write, the resonance effect is defined as the polarity produced in the molecule, the polarity produced in the molecule. So the very first thing that comes in our mind about resonance effect is that there is a polarity that produced due to the resonance effect. The polarity produced in the molecule by the interaction of two pi bonds. How this polarity is produced? This polarity is produced in the molecule by the interaction of two pi bonds, by the interaction of two pi bonds. There is one more way by which, or between a pi bond and a lone pair. So please remember, my dear students, that this interaction which causes the polarity may be between the two pi bonds, or my dear students, or between a pi bond, or between a pi bond and lone pair of electron present on an adjacent atom. Between a pi bond and a lone pair of electron present on an adjacent atom. So please remember, my dear students, that due to the resonance effect, the polarity is produced in the molecule. This polarity is produced by the interaction of two pi bond, or this polarity is produced by the interaction of a pi bond and a lone pair present on the adjacent atom. So this is how, my dear students, we can define the resonance effect. Now, if you could not understand anything, you can ask me, Bacho. बच्चों ये जो मैंने रेजोनेंस इफेक्ट आपको समझाया है, उसमें अगर आपको कुछ समझ में नहीं आ रहा है तो आप लोग मुझसे पूछ सकते हैं। कुछ पूछना चाहेंगे बच्चों? Okay, then let me write some of the characteristics of this resonance effect. The first characteristic is that this effect is transmitted through the chain. This effect is transmitted through the chain. So please remember, my dear students, that this effect is transmitted through the chain. Now let us understand uh, about the resonance effect and its various types. So what are the various types of resonance effects? So there are two types of resonance effect. There are two types of resonance effect. There are two types of resonance effect. My dear students, we have another name for resonance effect. Another name for resonance effect is the another name for resonance effect is mesomeric effect. Mesomeric effect. So the another name for resonance effect is mesomeric effect. Let us see, there are two types of resonance effect, my dear students. The first one is called positive resonance effect. Positive, sorry, positive resonance effect, which is also represented as plus R effect, or we can even call it as plus M effect, which is positive mesomeric effect. Positive mesomeric effect. The another type of effect, resonance effect, is known as the negative resonance effect, or we can write it as a negative mesomeric effect. And that is what we represent it as a plus, sorry, we can represent it as a minus R effect, or my dear students, we can write it as minus M effect. So, my dear students, let us study now this various effect. Let us start studying with the plus R effect. That is your positive resonance effect. Now in the definition we have seen that this is the kind of effect that takes place due to the interaction of the electron of pi bond and a lone pair. So let us study this with the example of aniline. Please remember, my dear students, that the compound NH2 bonded with the benzene ring, this nitrogen has got a lone pair, This compound is known as aniline. So now, my dear students, let us study how this resonance effect takes place into the aniline. You can see that I have drawn the structure of aniline, and in this structure of aniline, my dear students, we have the lone pair present on the nitrogen. Now we are going to show the various structures in which this kind of effect is observed. So I'm just going to show you the various structures and how this effect actually works in a different way. So let us study this, my dear students. I hope you can see the screen clearly. बच्चों आपको स्क्रीन जो है वो clearly दिख रही है?
Yes, sir.
Okay. Now see what happens. This is your aniline. This is the lone pair, and this is the double bond. You can see. This is the double bond. You can see it easily. And this is the lone pair. Now what happens? The electron from the lone pair, they move in this direction. And due to that, these two electrons present in this double bond, they moves on this carbon. I hope you understand this. So what happens here, my dear students? There will be double bond between the nitrogen and carbon. Due to the movement of electron, there will be slightly positive charge on nitrogen, and there will be a negative charge on this carbon due to the presence of lone pair of electron, and this two bond remains the same. Now in the next case, what happens, my dear students, that this electron will move here, and this double bond electron will move on this carbon. So again you will get a negative charge on this carbon with two lone pair of electrons. Due to the movement of this electron here, you will get the double bond produced. There will be double bond between the carbon and nitrogen, and a slight positive charge on nitrogen. This is what it happens. Then in the next, my dear students, again what happens? These two electrons, they move and they create the pi bond between the carbon, and this double bond or pi electron, they move on the next carbon. So the carbon get negative charge with two electron present with it. Here we have generated, or here we have a pi bond. There was already a pi bond present over here, and still there is a double bond between the nitrogen and carbon and a slight positive charge on nitrogen. This is what it happens. Now, my dear students, you can see that this electron which are present on this carbon, this electron move in this direction and they create the double bond. And the double bond which was present between the carbon and nitrogen, the electron from the double bond move and they go to the nitrogen. This is what it happens. So now, my dear students, you can see that on nitrogen you get your double bond, your lone pair. The nitrogen get its lone pair, so the double bond is being removed. Then the new double bond is created, and then you can see that. And then, my dear students, from this structure, by the movement of the pi electron in this manner, if this double bond moves in this double bond moves to this, and this double bond move to that carbons, you can get these structures. So if you look into this, you will get some 5 structures. This is 1, this is 2, this is 3, this is 4, this is 5. Now, if you note down, my dear students, you will realize that there are 3 structures. There are 3 structures with charge distribution. With charge distribution. and positive charge on nitrogen and negative charge on carbon. So now if you compare, my dear students, you will realize that this is what it is not according to the rule of resonance, and that is why this uh, this canonical form number 2, number 3, number 4 are going to be the least contributing structures. So structure 2, structure 3, structure 4 will be contributing very less, and structure 1 and structure 5 will be contributing to a greater extent into the hybrid structure. So this is how, my dear students, we understand here the positive resonance effect, or we can say plus R effect. This effect is also known as the positive mesomeric effect. Let me note it down for you, my dear students. This effect is also known as positive M effect, or you can write it as a positive mesomeric effect. बच्चों, अगर कुछ समझ में नहीं आ रहा है तो आप लोग पूछ सकते हैं. दिस इज व्हाट इट इज नोन एज द पॉजिटिव रेजोनेंस इफेक्ट. अगर आपको कुछ इसमें समझ में नहीं आ रहा है तो आप लोग मुझसे पूछ सकते हैं. डियर स्टूडेंट्स, प्लीज रिप्लाई. आई एम एक्सपेक्टिंग एन आंसर फ्रॉम यू.
No doubts.
यू आर श्योर दैट देयर इज नो डाउट? Okay then, my dear students, I hope you understood. Let us study the same effect with one more example. One more example for plus R or plus M effect. The another example we want to study, my dear student, is for a compound which is known as phenol. Please remember, my dear students, we want to study this for the compound. This compound is known as phenol. So let us study the effect here in detail, my dear students. We have phenol. You can see I am going to draw the structure of phenol. This is oxygen and hydrogen. Oxygen has got some 2 lone pairs, and there are 3 bonds present into the benzene ring. This is what it happens. Now, as we know that in general we will have 5 resonance structures. So let me draw at least a ring for you, my dear students, so that we can understand the movement of pi electron and lone pairs for us. Let us write OH also in all these cases. Okay. Now, my dear students, let us see what happens one by one. You can see that this lone pair of electron, they again come to the carbon and oxygen bond, and there you get the carbon oxygen double bond. So again, the double bond is generated. As the number of electron or as the lone pair is removed, there is a slight positive charge on the oxygen, and then, my dear students, you can see that this electron goes to the carbon and there will be a negative charge on this carbon. It is very easy to understand this. Please remember, please remind, my dear students, please remember it well. Now, my dear students, we have this, there is a double bond. Now you can see that this electron moves to make a double bond here, and this electron will go on carbon to generate the negative charge. So carbon number 4 will get the negative charge, and there are 2 double bond, and still the oxygen has got positive charge. Now, my dear students, what happens? You have positive charge on oxygen. Please remember that this oxygen has got lone pair of electrons. So there is a lone pair of electron. Now in the next, what happens? This electron goes to the goes to make the pi bond, and the pi bond electron goes on carbon to generate the negative charge. So here we have the negative charge on sixth carbon. There is a double bond between the fourth and fifth carbon and the second and third carbon. And this is how we get the next structure. Now, my dear students, what happens in the next? The electron from the carbon goes to make a pi bond. Still there is a double bond, my dear students, still there is a double bond between the uh, carbon and oxygen, and that double bond electron actually goes to the oxygen back. So oxygen gains the electron and the positive charge, a slight positive charge is vanished, and then you can get the double bond produced between the carbon number 1 and carbon number 6. There is a double bond between the carbon number 4 and 5 and carbon number 2 and 3. Thus we get this kind of structures, and oxygen has got its both the lone pairs back. And now, my dear students, we have got the structure number 5th, and from this 5th structure, by the movement of just the pi electron, we can get the first structure. So please remember, my dear students, that here we have got the structure number 1, 2, 3, 4 and 5 structures, and this is again we have the positive resonance effect or positive mesomeric effect. So बच्चों, अगर कुछ समझ में नहीं आया तो आप लोग पूछ सकते हैं. Dear students, do you have any doubt?
No, sir.
Okay. So let's move and study about the negative resonance effect. Let us study about the negative resonance or mesomeric effect. So let us study which is represented by minus R or minus M effect. Now, my dear students, here we are going to study one compound which is known as the nitrobenzene. So let me draw a structure of nitrobenzene for you, my dear students. When the benzene ring has got NO2 on it, it is called nitrobenzene. So we are going to study the effect for nitrobenzene here. Please mind well, my dear students, this is nitrobenzene. So let me first draw the structure of nitrobenzene first. So this is your nitrobenzene. In nitrobenzene we have NO2 group. So there is a bond between nitrogen and oxygen, and there is a double bond between the another nitrogen and oxygen. And this is how you show. And this nitro NO2 group is bonded to the benzene ring. You can see here. Now please mind well, my dear student, that where I have shown the arrow, that means the electron for the bonds are given by nitrogen, and that is why this oxygen has got 6 electrons. But where there is double bond, my dear students, this oxygen has got 4 electrons as a lone pair. And this is how we can show the various electrons. Now we will study how do we get the negative resonance effect or mesomeric effect. Here also we will get some 5 structures. So let me draw the basic structures for you, my dear students. So these are the various structures that we can understand. Now let us understand how the electron moves and how this effect takes place. So first of all, my dear students, you can see or you are well aware that the resonance effect takes place due to the movement of the either two pi electrons or the pi electron and the lone pair. So here in this case, you can see that this is the pi bond and the electron from the pi bond go on oxygen. And thus, my dear students, out of these four, instead of these four electron, there will be six electrons present on the oxygen, and there is a negative charge produced on the oxygen. Now, when this happens, this this electron from the double bond go to the carbon. So what happens? So what happens, my dear students? Actually, this is what it not happens. But this electron from the double bond go and make the double bond between the carbon and nitrogen. So there will be double bond on carbon and nitrogen. And my dear students, there is a negative charge on the oxygen. And due to this, this carbon has got double bond shifted from one side to another side. But this carbon lost this electron, and that is why there is a positive charge generated on this carbon. We already have two electrons present. Now in the next step, my dear students, what happens that this electron of pi bond, they move and they this electron of pi bond, my dear students, they move in this direction. So you can see that there will be a double bond generated here. This electron moves, so there will be double bond generated here. But this carbon has lost electron, and that is why there is a positive charge generated on this carbon. The double bond are as usual, and the negative charge on oxygen is also as usual due with the 6 electron on this oxygen. 6 electrons are already present in all in the oxygen with the bond where the electrons are given by nitrogen. So this is how we show it. Now you can see that the positive charge has moved in this direction. So we have got, this was the structure number 1. We have got structure number 2. Now let us see how do we get structure number 3, my dear students. Sorry, we have even studied how do we get the structure number 3. So we have got structure number 3. Now how do we get structure number 4? That is what we understand. So you can see that this, there will be double bond between carbon and nitrogen. This electron between the carbon number 4, 5 and 6, they move and go to the carbon number 1 and 6, and that is why they create a double bond here. Uh, let us say this double bond which has never moved at all, that moves to this carbon, and we get a double bond formed over here, and we get a positive charge on this carbon. This bond remains as usual. So this is how, my dear students, and you can see that there is a negative charge on oxygen with 6 electron present on oxygen this way. So we have got the structure number 4, my dear students, from structure number 3. So there is a movement of electron. Now what happens? Let us see how we get the structure number 5 from structure number 4. So still there is a double bond between the carbon and nitrogen, and thus this electron from carbon and nitrogen double bond, they come between the carbon number 1 and carbon number 6, and 2 electrons from oxygen, they come back to the, they come between the nitrogen and oxygen bond. Thus, nitrogen and oxygen double bond is formed. This oxygen has got 4 electrons as a lone pairs present on it. There will be double bond between carbon number 1 and carbon number 6. And you can see that there are double bonds present between carbon number 2 and 3 and carbon number 4 and 5. So thus we get the resonance structure with which is, we call it fifth number. And then by the movements of the pi electron, we can get the structure number 1 from structure number 5, my dear students. So this is how you can understand. And this effect is known as the negative resonance effect or negative mesomeric effect. Please understand well, my dear students, that this is what it is seen into the cases where there is a double bond present in the group which is linked to the benzene ring. So this is how, my dear students, we understand about the negative resonance effect. बच्चों अगर इसमें आपको कुछ समझ में नहीं आया, if you have any doubt, you can ask me. Dear students, have you understood this? बच्चों ये समझ में आया है? Please reply fast.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, dear students. So let us study this effect with one more example. Suppose we have benzaldehyde. This compound is known as benzaldehyde, my dear students. We have C double bond O and H. This is what it is known as benzaldehyde. So let me show you how we can show the negative resonance effect in the benzaldehyde. Let me show it to you, my dear students. How will we get the, or how do we understand the negative resonance effect into the benzaldehyde? When it comes to benzaldehyde, my dear students, there is a double bond between carbon and oxygen, and there is a hydrogen present on the carbon. You can see that we have the 3 pi bonds present, and this is what it gives us the first resonance structures into the benzene. Now we will show the movements of oxygen. You can see that this oxygen has got 4 electrons on it. Now what happens? This electron of pi bond between carbon and oxygen, they go to the oxygen, and the electron of pi bond inside the benzene ring, they go between the carbon and aldehyde carbon. Thus there is a double bond created here, and then you have oxygen with the 6 electron as a lone pair and a negative charge on it. There is no change into the bond between carbon and hydrogen, but there is a positive charge generated on the carbon number 2. Now you can see, my dear students, that from the carbon number 2, if the electron between the carbon number 3 and 4, which is a pi bond electron, if they move towards the bond between carbon number 2 and 3, we will get a double bond between the carbon number 2 and 3. We already have a double bond between the carbon number 6 and 5. There is a double bond between the benzene carbon and aldehyde carbon, and there is a negative charge on oxygen with 6 electron as a lone pair, and we have a carbon hydrogen bond. So we have got the structure number 2, and from structure number 2 we have got the structure number 3. Now let us see how we get the structure number 4 from structure number 3. So here you can see that the pi bond between the carbon number 5 and 6 moves, and it goes to the carbon number 4 and 5. So there is a double bond created. There is a double bond between carbon number 2 and 3. Again, we have the double bond between the benzene carbon and aldehyde carbon, carbon hydrogen bond, and still oxygen with negative charge having 6 lone pair of electrons. This is how we see it. Then, my dear students, we have the next one. Here, my dear students, you can see that the electron present here, they move in a way that the electron from the carbon of aldehyde and benzene ring carbon, they come between the carbon number 1 and carbon number 6. So there is a double bond produced between the carbon number 1 and carbon number 6. There is already double bond present between carbon number 2 and 3 and 4 and 5. Now what happens, the electron from the oxygen, they come to the carbon oxygen bond, and we can have carbon oxygen double bond formed into the aldehyde group. There is thus on oxygen there are only 4 lone pair electron are left, and we have got the 5th resonance structures. And from this 5th resonance structures, just by the movement of pi electron, my dear students, we can get the first resonance structures. And this is how, my dear students, we can understand the negative resonance effect in benzaldehyde. This compound is known as benzaldehyde. So I hope, my dear students, now you have understood it well. बच्चों, अगर अभी भी इसमें कोई डाउट है तो आप मुझे पूछ सकते हैं. बच्चों, कुछ पूछना है?
No,
No,
sir.
sir.
Okay, so you have seen that if we have a benzene ring that is bonded with the group that has got lone pair of electrons, and if the lone pair of electrons involves into the benzene ring, and a carbon of benzene ring gets the negative charge, this type of effect is known as the positive resonance effect.